Okay, so again, I have the little PWM generator board driving the power MOSFET board, driving the motor, and here on the oscilloscope we can watch the PWM signal. Let's take a look at that. Right now I'm pushing the button on the PWM board and adjusting the potentiometer to more or less duty cycle, and it jumps pretty quickly there sometimes. 75% is about the best we can do with this motor. Can't go much slower than that with this little driver board. So what we're going to do next is use the PWM signal from this board through the driver to the motor to vary the speed of the motor. I think you'll hear it, and I'll try to get where you can see it too on the tachometer and on the oscilloscope, try to get the duty cycle. Anyway, let's start up the power supply. Pow! Got about 65 volts here. Let's see, excitation is active. Let's think about this. I guess the next thing I have to do is just push the button and the motor should start. Let's look at the duty cycle. Nope, not enough. Let's crank it all the way to max. There. The motor has started. Motor maxed out somewhere around 750 RPMs. And the current, which you can see right up here, is about 1.5 amps, give or take. That's at about 100% duty cycle. Alright, let's do this next. Let's adjust the duty cycle, maybe down to about 75%. Okay, at 75% duty cycle, the motor is barely turning. It's 31 RPM. I think that's correct. Nope, it's not turning anymore. It stopped. Okay, let's see what we can do here. Watching the motor, watching the motor. Okay, that's about the slowest we can get out of the motor. That's about 120 RPM. Here's our duty cycle, somewhere around 75%. So again, it's all coming from this little control board through this pretty small driver board. So we can use relatively small components to control a relatively large motor like this one. Let's just look here at one more thing. Let me turn the duty cycle up to max. With this little push button I can start and stop the motor. And let's take a look at that. I think you can hear the motor. And you can see the motor. Okay, the next thing I'm going to do, since we're just about done with this board and it doesn't matter so much if we damage it, I'm going to turn on this cooling fan to try to cool the heat sink if it gets hot, and it will get hot. Not much of a heat sink there, but it helps. So we'll turn that on. Let's crank up the voltage just a little bit. Bring it up to about 90. Now let's see if we can still start and stop the motor with this one little push button. Sure can. And I release the button, motor is spinning down again, and there we go. See if I can take it higher still. Let's take it up to 100 volts. Okay, we're looking at about 1.5 amp steady state current up here. I don't know if you can see that meter. The motor is doing great. It's about 1300 RPM. Let's see if I can adjust the duty cycle and adjust the speed. Okay, let's try this again. Motor's running, adjusting the duty cycle. Let's say 1300 RPM, duty cycle, bringing it down just a little bit. Yeah, down to about 75%. Speed is coming down. Motor's still looking good. Transistor hasn't burned up yet. That's a good sign. Let's see what the lowest duty cycle we can get is at this voltage. Whoops. Alright, we've started the motor again. Bringing down the duty cycle, bringing it down, bringing it down. Motor's still running. Still running. Running pretty slowly though. Running very slowly. It's about 150 RPM. Nope, it just stopped. Bringing it back up again. Here we go. Nope, I'm afraid it's running at full speed now. I think we've burned up our little transistor. So, that was our demo for today. Hope you enjoyed it.